Hello everyone, and welcome to the Esri GeoDev webinar series. We started this series as a way to continue engaging in developer-related topics and discussions in between Dev Summits. We are looking forward to our next Dev Summit conference, which will take place March 8th through 11th, 2022. Moving forward, in continuation of our GeoDev webinar series, we will continue to have new topics, advanced features, and additional functionality to share with you, so be sure to stay connected with us through our GeoDev webinar series page or any of our social media accounts at Esri GeoDev. We would love to have conversations like these taking place throughout the year, so that when we do meet at one of these Dev Summit conferences, it will be as though we never stopped. We hope you get as much or more out of this webinar than you anticipated. Now, we would like to introduce you to our webinar, a tour to different modules in ArcGIS API for Python. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right corner. You're listening in using your speaker systems by default. If you would prefer to join over the phone, just use the use telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce you to one of our presenters, Chunming Peng. Chunming, let's get started, shall we?
Hello everyone, welcome to the GeoDev webinar session with Esri, titled A Tour to Different Modules in ArcGIS API for Python. My name is Chunming Peng. I work for the ArcGIS API for Python team. Today, together with my teammate John East, who's a senior product engineer and also a domain expert in ArcGIS API for Python, we will walk through some of the amazing modules and their functionalities within the API. The session will be organized in 3 parts. First, we will start with some introduction to the API's basic concepts, environment, and setups. Then we will try to reinforce your impression to the API with some real examples and codings. At the end, there will be a 15-minute Q&A session. So please feel free to type in your questions and we will try to address them at the end. Also, just a heads up, we are assuming that all the audience have some knowledge of Python programming. Because we are not diving into any Python syntax or structures today, the session will mostly focus about ArcGIS API for Python itself. All right, everyone ready for the tour? The ArcGIS API for Python is a powerful, modern, and easy-to-use Pythonic libraries to perform GIS visualization and analysis, spatial data management, and GIS system administration tasks, and can be run both in an active fashion as well as using scripts. For powerful users, system administrators, and Python developers, the API enables them to automate their workflows and perform repetitive tasks using Python scripts. On the other hand, for the academics, data scientists, and GIS analysts, they can use Jupyter Notebook and share their geo-enriched programs with the society. Now, what can ArcGIS API do for you? If you are an administrator, the API can help you manage users, roles, groups, or items on your enterprise or your ArcGIS online organization. Or if you're into data management, the API can help you publish, edit, update, or delete your online content. And also for spatial analysis, location analytics, and other platform-related functionalities, you can find its implementation in the ArcGIS API for Python as well. Before we can use the API, the first step is to install the ArcGIS API for Python. It is distributed as ArcGIS package on pip or conda, and the detailed instructions can be found on these websites. After successful installation of the API, we now need to get hold of a good-to-use IDE environment. For example, you can use the Jupyter Notebook that naturally comes with the previous installation. If that's not enough, and you want to do more debugging, you can install the free versions of Visual Studio Code, PyCharm, PyScripter, or you can purchase the licensed ones, for example, the Win Python IDE. Now you have the API ready and you have your IDE at hand. You are ready to perform some real coding. There are so many different modules that is grouped under the API. For example, with the GIS module, you can manage your online organization, your GIS, your items, your groups, your roles, etc. And with the ArcGIS.features module, you can interact with the features data, the features layers, or the collection of feature layers. Let's tour these different modules with a real story. We all have heard of the Dixie Fire, which started on July 13th and had burned more than 980,000 acres. Up to today, the fire isn't completely put down, with 86% of it contained. The fire has been burning in 5 counties of California. The drought, combined with hot weather, strong winds, and dry vegetation, make the fire really active. Now, let's pretend we work for the Civic Planning Department of California. And then we try to see if the ArcGIS API for Python and the Jupyter Notebook environment can help us solve these questions. For example, are there any highways that intersect with the impacted burned areas? Is any of the interstate highways too close to the wilderness preservation areas? Also, in the Dixie Fire situation, are the wilderness protected areas in a safe distance from the fire incidents? Also, we are concerned if any of these counties are impacted by Dixie Fire to these vulnerable populations. For example, the number of populations with disabilities, low household incomes, no medical insurance, or the elderly groups. So now, like always, we have to import the necessary libraries first, and then create a GIS connection object to the ArcGIS Online organization. So here we are trying to connect to ArcGIS Online with username, password. Here we touch the concept of the GIS module. Let's take a look at the object model diagram of GIS. So GIS is an object that represents either ArcGIS Online or ArcGIS Enterprise. The important concepts of GIS include content, users, groups, roles, items. So in the notebook, we're going to see how we do gis.content.search to search for items. And then we are getting the layers from each item by getting the properties item.layers. So take a look at the signature of these functions. When we try to initialize a GIS object, we can do GIS, and then we specify the URL to the organization or to the enterprise. And then we can do either username password combination, or we can choose to use client ID or an existing profile. Later, we're going to see when we search for existing items, we're doing gis.content.search. And in there, we have to specify the query string. And optionally, we can specify if the item type is a feature layer, a web map, or other types, or if we want to search outside of the organization. Another popular usage of the GIS connection object is gis.map. It will quickly render a map view. And if you want to make the mapping more specific, you can specify at which location the map is going to center at which zoom level, if it's 2D or 3D mode, and if you want to use your customized geocoder. So this is for the GIS module that we are going to touch in the presentation. Also, we are going to soon see some usage of the features module. So we are going to see how we access the feature layer and how we could perform query to get feature set out of the feature layer. And when you specify some parameters, such as the SDF parameter, you are then getting a data frame out of the query instead of features. So after you've done the search, you've come back with the item type. If you do item.layers, it's going to return you, for example, in this case, a feature layer item. And then you can do layer.query to get back features or data frames, depending if SDF is set to true or false. And in the query call, we can specify the where clause, the out fields, if we are applying time filter, geometry filter, and if you want the geometry to be returned, or if you want count only, IDs only, extent only. So these are optional. When SDF is set to false, you are getting feature set in the return type. And then you can do feature set.features and see how many features are inside one feature set. So that's the basic walkthrough of the functions that we are going to see for a features module. Now let's get back to our example. We are now trying to get the data sources from feature layer, from existing feature layers. So the first search is for US freeway system. And then we're getting a feature layer connection. We are getting a feature layer collection that represents rural and urban interstate highways. And then we're trying to do items.layers. And the first layer is the feature service. The second data source is coming from US current wildfires. So the search operation still returns a list of results. And the first one is the closest match. And in this case, that's the feature layer collection that shows wildfires updating within the past 7 days. And also note that there are actually 2 feature layers inside this item. So the first layer is the center, is the fire center. So we can do wildfire layer.query, and we specify the where clause to be Dixie Fire inside of California. And when we do a for loop and get all the features out of the feature set, we can see that there's only one record that corresponds to the search, to the where clause. That is Dixie Fire, a wildfire, and the acres is 960,000 something. So this is really detailed. We can also see how many days has passed since it's discovered. 64 days. The second layer for the feature layer collection is actually the fire's perimeters, which returns as polygons. So same here, we're doing incident name search, and then we are getting the Dixie Fire happening inside of California. And for the third data source, we're trying to get the wilderness areas. So we are searching the keywords in the keywords in the title, the item type as feature layer, and we allow it to be searched outside of the organization. And the first matched result is just the web item that we want, the featured collection of wilderness areas. And like before, we're trying to get the first sublayer, which is the feature layer for wilderness areas. So far, we have managed to use features module to query for an existing feature layer collection item, access the feature layers inside these items, and then further extract features from the feature layer. What about geometries? Say we're going to visualize all these data sources on the map view, but we also want to know what are the boundaries of these 5 counties that are impacted. All right, we're going to use the geometry module to provide the county boundaries. If you are new to the geometry module, what's really helpful is go to the ArcGIS developers website at developers.arcgis.com/Python and check out our guides and sample notebooks. For example, if you go to guide, working with geometries section, and then in part 1, we'll talk about the basic concepts of geometry module. In part 2, it will be focusing on how you create geometry objects and how you extract geometries from existing feature layers. And in parts 3 and 4, we will talk about advanced topics about the geometry module. So let's take a look at the object model diagram first. The geometry is naturally a property of a feature object. When you have a feature at hand, you can just do .geometry to access its property. And when we're talking about geometries, we are actually talking about points, polylines, and polygons. For example, the wilderness preservation area is a polygon layer. One way to getting geometries from feature objects is usually when you get hold of the feature set object, you do featureset.sdf to have the spatially enabled data frame ready. With the spatially enabled data frame, you can then do .spatial, and it's going to return the geometry. For example, here we are looking at the DC's tax incentive polygons. The other way is to retrieve the geometries from Geo Enrichment Module, which we're going to mention shortly in the next step. For now, we're going to stick with the geometry module and introduce more functions. So we're going to see in the notebooks multiple examples of creating geometry filters, one of which will be creating an intersects geometry filter. So in the example, we will need to specify which geometry we are associating with, and then if we want to specify a spatial reference for this intersecting behavior. Once the geometry filter is created, we can then pass along to the feature layer.query function. So in this sense, we are trying to apply the geometry filter created in the previous step and check if in the feature layer, there are any features that meet the requirements of the geometry relationships. For example, if we want to check if there are any interstate highway that intersects with the wildfire, that will mean that we are creating an intersecting geometry filter with the wildfires. All right, so these will be very often seen in our examples. Once we have the feature layer ready and also we have the geometries extracted, we will then use mapping module to visualize them on the map view. For example, we're going to use mapObject.addLayer to add the feature layers onto the map. In the options parameter, we can specify the renderer options. If you are not satisfied with the zoom level, you can use mapObject.zoomToLayer to zoom to the specific feature layer or other layer types you have just added to the map view. Again, if you don't like the current display, use map_object.remove layers to remove all the work you have added. Besides layers, you can also add graphics to the map view. For example, when you have a geometry object, which is usually extracted from feature layer, feature set, or from a spatially enabled data frame, you can do map_object.draw, and then you can specify the pop-ups, the symbologies, or other additional attributes to be displayed on the map. Again, if you don't like the graphics that you have added there, use map_object.clear_graphics to remove all the graphics that's being added. At the end of the day, if you want to save all the work, use map_object.save and specify the item properties, for example, the name, the descriptions, the tags, the keywords, etc. And then you're going to persist the results. All right, enough with the introduction. Let's take a look at the real codes. So first, extracting the boundaries from Geo Enrichment Module. Since we're going to discuss about Geo Enrichment in the later steps, we're going to go straight to here. Once we have the named area object ready, we can do object.geometry to retrieve the geometries from any administrative area or a dynamic area provided by Geo Enrichment Module. So this is for a single county. We're going to do a for loop and get the other 4 named area objects. And then we are going to use the union function of the geometry module to perform a union operation of all the 5 geometries derived from the named area objects, representing the 5 counties at risk. And here we are seeing a preview of the union result. Now we have the data sources ready. Let's go on to map them. With the help of ArcGIS.mapping, we can do map initialization with the center set to Plumas National Forest and with the extent set to be the same extent of the union result of the 5 counties. And then we can go on to add the data sources. When we're adding the geometries, we are using map_object.draw because we are inputting each county's geometry object. The reason that we're doing the draw actions separately for these 5 counties is that we want to see the state lines in between. Then we are using map_object.addLayer to add the feature layers. For example, we want to add the interstate highway, the wildfire parameters, the wildfire centers, and the wilderness preservation areas. So now we are looking at a map that contains all these information, which is a good beginning. Yet we also wonder, among all these wildfires, which ones are actually happening within these 5 counties? And is the interstate highway somehow hampered by any of the wildfires? Lastly, are any of the wilderness preservation areas at risk because of the wildfires? The ArcGIS.geometry.filters submodule is going to help us answer all these 3 questions. So first, we will need to create a geometry filter. Just simply input the county's geometry and then specify a spatial reference. With the geometry filter being created, we can then use a feature layer.query function to apply the geometry filter. So in this cell, we actually want to know inside this Butte County, what wildfires have intersected with it. And we are setting SDF to true, so we can see the result being displayed in a spatially enabled data frame. Inside the Butte County, only 1 fire is spotted. That's the Dixie Fire. All right, and now we are doing a for loop for the other 4 counties. The steps are similar. We are creating geometry filter, and then we are using feature layer.query to apply the filter. So we are seeing that for the other 4 counties, there were 2 wildfires for each of them. So besides Dixie, there's Sugar, McFarland, and Dixie and McFarland are spotted in 2 counties. And the second question, are there any interstate highways that are being hampered by the wildfire? In order to get this information, the first step is to check if there are any interstate highways that go through these 5 impacted counties. So first, we are creating a geometry filter. That is to check if any geometries will intersect with the union of the 5 counties that we created previously. And then we are applying freeway layer.query function and apply the geometry filter here. Then we are setting SDF to true, meaning that the output result of this function will be a spatially enabled data frame. Then we are printing out the columns that we want. So actually, there is one single interstate highway that is going through these 5 counties, which is the I-5. Now let's get more details about this I-5 layer. All right, we're again using freeway layer.query function. And now we're specifying the where clause to be route number equals I-5. And still we're applying the geometry filter to be intersecting with the union of the 5 counties. And now we are getting back a feature set instead of a spatially enabled data frame. If we loop inside the feature set and check all the features, we can print the attributes out of each feature and even display the rough shape of the geometry per feature. So now we are looking at the shape of I-5. Isn't it similar to what we are seeing previously in the map that we draw here? The I-5's interstate highway. We are going to skip some of the contents and go directly here. So we have already known there are 3 wildfires reported in the Union Polygon of the 5 counties at risk. What are the wilderness protected areas that will be impacted by the fire? So here, we're doing a for loop to process all the 3 wildfires. The major step will include creating a buffer area for each of the wildfire occurrence, and then creating a geometry filter for the buffer zone. Then we are choosing the wilderness protected areas feature layer to perform query based on the geometry filter set to intersecting with the fire buffer zone. When we print the result, we're seeing actually for the 3 wildfires happening inside the 5 counties, there will be 2 wilderness protected areas that will be impacted. So let's visualize the future results. Now we are going to initialize the map view again, centering at the forest. What's different here is that we are setting the zoom level and then we are modifying the height inside the layout. So this will be a longer map. All right, and what we are doing here is first to draw the wildfires. Remember the 3 wildfires we talked about? And then we are drawing the buffer zones, which is actually a little larger than the file areas. So it's going to overlap the first layer completely. And then we are going to draw the wilderness areas that are affected by the wildfires. There are 2 features inside the list, so it might be a little difficult to see here, but the first one, the wilderness protected area being impacted, is shown here, and the second one is here. Next, we want to decide what secondary roads and local roads might be affected by the wildfires. So we have to first create a feature layer object from the transportation resources provided by Census Bureau. So what we are seeing here is actually either you search for the transportation large-scale feature layer, or you specify the URL yourself and create it out of scratch. No matter which way you pick, our goal is to have the secondary roads layer and the local roads layer ready. And the subsequent workflow is quite similar. So we are still looping through all the files, and we try to have the secondary roads layer query based on if the feature's geometry intersects with the file's buffer zone. If so, we are adding the results into our list. And then we're doing the same query operation for the local roads layer. And if there are any local roads that intersect with the file buffer zone, we're again adding it into the output list. So at the end, we are going to visualize the secondary roads and the local roads in the dotted blue lines. So we can see here the local roads are shown in a lighter and smaller dots, while the secondary roads are in a darker blue. So these are the two transportation road segments that will also be impacted by the wildfires. Now we have already talked about getting the information from feature layers, and we're adding the geometry as shape, and then we're performing geometry filters to get all the spatially relative results. Next, we want to know what population groups in these 5 counties are most vulnerable during the Dixie Fire. With the help of Geo Enrichment Module, we already see the convenience of deriving the geometry of all these 5 counties. And what other advantages can we seek from using Geo Enrichment in getting statistic results? Let's pause here for a minute, and I really want to circle back on the guides page where you can find on the developer's website. The information provided here are really helpful for beginners and intermediates. For example, if you want to know about Geo Enrichment Module, you can check out Enriching GIS Data with Thematic Information. And the topics listed below go from introduction to basic concepts of geoenrichment to what are study areas, named statistical areas, data collection and analysis variables, or even to more advanced topics. For example, how you generate reports and how you can compose standard geography queries. The resources put here are really refreshing and helpful. Even us who are working on the product every day need to come and check really often. All right, now back to our thread. So usually when it comes to USA local data, we will start by importing country from ArcGIS.geoenrichment, and then we are using country.getUS to have the geoenrichment country object ready. With this geoenrichment country object, we can then do .search to search for USA's places that would meet the specific query string. For example, we are going to do USA.search, and then in the query string, we have put the county name, and then we specified the administrative level to be US counties. In doing so, we are getting a list of named areas that match the query string. So in this case, there's only one named area object in the list. So we have already seen how the geometry can be derived here. Next, we just look at how other data collections can be taken advantage of. For example, if we do USA.data collections, we are getting a data frame that have all the data collections specifically made for the USA. With this data frame ready, we can choose what data collection ID we want and what analysis variable we want to do enrichment, buffer study area, and other related operations. For example, if you want to do enrich, which is just going to fill in all the columns inside one data collection to your result data frame, you will have to specify the data areas, the data collection IDs, and the analysis variables. And also in a later example, we'll be using buffer study area to initialize a dynamic named area object that you can buffer point, street address randomly. Now let's take a look at the real implementation. If we do dataframe.index.unique, it's going to show you the unique list of all the collection IDs. So some of these are real familiar, like the housing summary, age, race profile, transportation, vehicles available, women, etc. So there are plenty of these data collections that we can choose from. But what interests me the most is the at-risk data collection, since we are trying to get what population groups are most vulnerable during the Dixie Fire. Let's take a closer look at the data frame. When the data collection ID equals at risk, what are the analysis variable and the alias? So we're actually quite interested in finding out the number of households below poverty lines and the number of households with at least one person with disability. What else? How many of these households use internet for the latest 30 days? And then the number of seniors. So these are the attributes that we consider related to if the household is more vulnerable during the Dixie Fire. So let's take a look at this data collection at risk. Now we are trying to do enrich and enter the named area, and we name the data collection to be at risk. This operation is to create the data frame that enrich the specific named area with all the columns that show up in the at-risk data frame. So now if we pull this data frame over, we are seeing all these attributes. For example, seniors, population, that used to be in the data frame when the data collection ID equals at risk. So this is for a single county. We're doing it this way. And what about others? So we can do a for loop that's doing enrich per county. But then we are actually appending one data frame to the other. So at the end, we will have a data frame that contains all the 5 counties located inside the burned areas. So we can see it here, the 5 counties. They all have been enriched with the at-risk properties. All right, now we are set. Let's go and visualize these properties on the map. So we initialize the map and center at the Plumas National Forest. We try to import the data into a layer. So in the real practice, we're actually using map.addLayer and adding the sublayer of the layer object into the map view. So right now we have specified a renderer type to be classed color renderer. And we want to focus at the number of households below poverty. So we can see among the 5 counties, this one is the one with the largest number of households below poverty lines. Again, the similar approach, but this time we try to focus at the number of households with disabilities. And then we have set the opacity to be 0.75. Again, the same county with the largest number of disabilities. Okay, going forward, we now are using the column that represents whether you have used internet for the past 30 days. So we assume that households that have no or less internet access will not know too much about the fire progress, and they might be more vulnerable. So here, we're doing the same approach. We're adding the layer to the map view and focusing on this field and with a specified opacity percentage. And the result is opposite. If we look at this county, it's actually with the largest number of internet access. Besides looking at those administrative areas like counties, states, or countries, we can also take advantage of geo-enrichment, but at dynamic areas. For example, drive time service zones. So here, for example, we try to find the 15, the 45, and the 90-minute drive time service zones apart from the center of Dixie Fire. So we enter the fire center here in the area parameter, and we specify a range of the driving time. And we specify the units, the travel mode, and we are creating a buffer study area object. This object will be passed into the enrich method, and it's going to create us a data frame that will have the 3 drive time service zones being enriched with the at-risk data collection attributes. So here we are going to see the 3 geometries. So let's again visualize these data frames on the map view. So first we create the map view focusing at the forest. And then we do data frame.spatial.plot, and we specify the map widget to be the Dixie Fire map. And now we are actually looking at the 3 service areas being rendered. I believe up to now, we all have found out how Geo Enrichment has done an amazing job of providing us convenience in finding out the geometries, the populations, and other statistics of administrative areas like counties, states, countries, and also dynamic areas for a random address. In today's presentation, we have walked through 5 modules together. The GIS module that enable us to connect to ArcGIS Online or Enterprise. The features module that we make search and queries of the feature layer collections and feature layer items. The geometry module that we use to derive the geometry from features and geo-enrichment objects. The mapping module, everybody likes, using mapping module to visualize our feature layer, our graphics on a single map view. And lastly, the Geo Enrichment Module that provide us with all the facts about places and people, providing us with statistics and geometries. So what we have done when we analyze the Dixie Fire, we have used existing feature layers on Living Atlas. We derive geometry using features and geo enrichment. And we learn all the interesting facts about places and people in these 5 impacted counties. And of course, we're using map.draw and map.addLayer to visualize all the desired results. And in today's session, we hope that you already found the answers to these questions. What counties are affected by the Dixie Fire? Are there other fires in these 5 counties? What interstate highways are impacted? And are there any wilderness protected areas being hampered? Also, what are the secondary and local roads that might be influenced in the fire? If you are concerned of the fire department dispatch, what are the service areas that are most rapid to respond to the Dixie Fire? Last but not least, what are the population groups that will be most vulnerable in the Dixie Fire? So we hope that everyone is learning something new from this session and get more interested into the ArcGIS API for Python. When you want to know more and if you have questions, please feel free to visit our developers.arcgis.com website for guides, samples, and detailed instructions. If you want to join us in a discussion, please visit the GeoNet community, or you can log an issue on the github.com. Last but not least, Another super helpful tool, the API reference page. For example, if you want to know more about the modules, submodules, classes, and functions that we have used today, you can just go to the API reference page. For example, the GIS module, the item class, the layer class, or you can search for the function. For example, you want to know more about add layer, you can go to the map view add layer page. The method signature is shown here. So the required input, which is the item object, the optional input parameter is a dictionary of your visualization options. Then you can see a simple use case here. For example, you are using add layer onto a feature layer object, and then you are inputting a dictionary of your renderers. All right, for example, you want to know more about geometry filters. Then you can just search for filters. Hey, you are seeing the filters module. So we have used the intersect geometry filter really often today. You are now seeing a complete use case of the intersect geometry filter, how you can create one and how you can apply it onto the query function. Besides intersects, we can also see like other geometry filter types, the contains, crosses, overlaps, within, etc. So the API reference is a good tool, and I definitely recommend you trying them all. And in the next 15 minutes, John and I are going to address the questions asked by the audience according to the popularity of the questions.
All right. Well, thank you, Chunming. We're now going to begin answering the questions submitted during today's presentation. We've received quite a few, and we will try to get through as many as possible, but whatever we do not get to today, we will be sure to address in the Esri community blog post after this webinar. As a reminder, you can still submit questions through the questions pane in your attendee control panel. I'll hand it over to John now to address the questions. John.
Well, hello there, everybody, and thank you again for attending. So we do have multiple questions. So let me go ahead and just dive right in and start to read the questions, and Chunming and I will we'll answer them as best we can. So first, I want to address the question we got the most is whether this notebook will be available to you, the attendees, and the answer to that is yes, this notebook will be available. I posted a link to it and sent it to everyone, so you should have it available through your webinar, the link to our public repo at github.com Esri ArcGIS Python API, and the full link has been sent to you. So on to some other questions. So this question we have, can I use the API to list all services published in my ArcGIS server? And Chunming, I'll take that. And the answer to that is yes, you can. You can access, there are various properties off the GIS module that allow you to dive into whether it's one server, a hosted server, or you have multiple servers configured with your organization. You can use the admin property to get to individual servers and use a service manager list command. There's also a services directory list command, which will allow you to navigate through the different folders on any particular server. So yes, the answer to that is yes. And the API reference, GIS admin module and server module will have samples on code snippets, how to do those things. So let's move on to the next question is the developer account independent from the ArcGIS Pro account? Or if I have access to Pro, can I just use that account on the developer sites and use those APIs? So I'm not clear what exactly is meant by the ArcGIS Pro account, but the developer account, you can connect to it from ArcGIS Pro, just as you can connect to your other organizational accounts. So you can navigate all your different accounts through the ArcGIS Pro interface, and you can use the Python API to interact with your content users and groups, etc., on that particular organization, whether it's in the developer account or an enterprise or online account. Okay, so next question. If my data has metadata, can I search a keyword in the metadata? Chunming, do you want to take that, or do you want me to take it?
I can answer a bit. Thank you, John. So
Sure.
if the keyword you used is like when you publish a service and the keyword you used is in our Elasticsearch somewhat popular and used by other users, then it's easier to be searched, and it will be reflected in the very beginning of the search results. But however, if your keyword is less popular, then when you get returned a search result, you will still have to search through. It might be lower in the ranking. What do you think, John?
Yeah, I was just going to add that if you can, when you search your items, there is a metadata property on the item object in the API, which will return the actual XML for the metadata. I don't know, I can't confirm 100%, but I suspect that the keywords within that metadata are not directly searchable, but there is a, excuse me, metadata keyword that is a part of any item that has been published with metadata. Excuse me, I got a frog in my throat. Okay, so we have a question about, are there samples to publish hosted feature service from ArcGIS Pro? We have samples to publish web maps and scenes. There are a couple different samples under the sample notebooks directory at developers.arcgis.com/python/sample-notebooks. There is a content publisher section, and there are samples to publish feature services from a variety of services. And there are, and in the Pro help, there's plenty of examples on how to share web layers from ArcGIS Pro itself. Chunming, do you want to add anything to that?
Yes, and I want to add a new trick coming in. So right now you can use the Jupyter Notebook also in ArcGIS Pro. So not only that you can publish manually from Pro's UI, or you can publish from our Jupyter Notebook outside of Pro, but you can also open the notebook inside Pro, and then you can do the publish and see the results directly reflected on your contents pane after that.
Yeah, next question. Is there a way to change the edit permissions using the API? I have many feature services. I need to enable editing and have the users only edit the attributes, not the geometry. Chunming, you want to take that one?
I'm not pretty sure because I haven't used it myself. But I do see some examples doing that on our developers' website.
Yeah, sure. You can absolutely edit the permissions of when you retrieve items from your organization. There is, for feature services in particular, if you have an item, you can grab an object called the feature layer collection from that. You can create that object from that item and use the properties of that feature layer connection to access the capabilities property, and you can read and set that property through the feature layer collection object. So yes, you can edit the permissions using the API. Next question is, can you configure the web app builder widgets through the Python API? Short answer to that is no. Chunming, do you want to add anything to that?
I think to my knowledge, we haven't support that action yet.
Yeah, you can, if you have a web app builder item, if you've searched that, you can use an operation on the item object, a method called get_data, which will return the actual JSON to you, and you might be able to configure the widgets through the actual JSON. You'd have to edit that JSON yourself, and then use the item.update method to update the item. So it would be you'd have to edit the Python or the JSON on your own. So let's see. The next, when we use the API for Python spatial operations on geometry, does the processing run locally like ArcPy or remotely in the enterprise or ArcGIS Online organization? Chunming, I'm going to let you handle that.
Can you please repeat the question?
Sure. When we're using the API, when we're using the spatial operations on geometries, where does the processing take place? Is it run locally on the machine where you're accessing the spatial operations, or remotely in the enterprise or ArcGIS Online organization?
Oh, thank you, John. So it would depend on what geometry engine you are right now set up with in your environment. Basically, if you are using, like, if you have ArcPy in storage, it will be using your local ArcPy environment that you have with your Pro or ArcMap. But however, if you haven't installed ArcGIS Pro on your machine, and then it will be pulling everything from the online geometry engine. It can be the online the online ArcPy or the online Shapely engine. I hope that answers the question.
Thanks, Chunming. And on to the next question. Are these geoenrichment operations consuming credits? Chunming?
Yes, they do. And depends on how large is the name area that you have specified. The charging is different. For example, if you are doing a county or a city level, then it's like every time 2 cents, I believe.
Okay, thank you. Next question, can you show in the code where the drive time ranges, once they're defined, were then pulled into the code to show on the map? I missed the function or variable call. I think, Chunming, I don't know if you want to dive through the notebook and show it, but can you explain the answer to that question?
Sure, let me see if I can still find the. Are you able to see the notebook?
Yes.
Sorry, it's. So basically, it is actually a combination of the network module and the Geo Enrichment Module. So in the network module, we have a function that will help you create service zones, and the drive time service zone is actually, okay, I found it. So it's similar to the function that we use to create service zones in the network module, where you specify the center point where you want to expand your circle with, and then you specify the radius. It can be either by driving time or it can be the distance. For example, right now we are using 15, 45, 90 minutes driving distance, but sometimes you can also do like 15, 45, or 90 kilometers. And this is the network module being used in the Geo Enrichment Module. So we are actually creating a Geo Enrichment buffer study area that we can then use to enrich with all the columns that you want for the specific data collection.
Okay, thanks for doing that, Chunming, and thank you all for the questions. I'm going to turn it over to Amy as we have reached our endpoint. Thank you again.
Thank you, John, and thank you, Chungming. Thank you, everyone, for attending today's webinar, a tour of different modules in ArcGIS API for Python. If you have any other questions, please contact me using my email address in your follow-up email. Once you leave today's webinar, you will receive a survey on the presentation, and we would appreciate it if you would complete that and provide your feedback. We will be providing a recording of this presentation, which will be available within 7 to 10 business days on the GeoDev webinar landing page where you registered. On behalf of Esri and our presenters, thank you for joining us today and have a great rest of your day.